in magnetism. So now we are in the chapter of magnetism. Before this, we were discussed about electrostatics. And this name, the Gauss, it is a name of scientist and it is very familiar with us. Why? Because we have heard of that name while we discussing the first chapter. So that Gauss has given one law in electrostatics, and it was about the electric flux. And where electric flux means it is the number of field lines which is passing through the given area. And he has given one equation to find out the electric flux through any area. The same scientist has also given a law in magnetism. And before getting into the Gauss law, we should have some knowledge. What I am going to say is, we already learned some properties of this magnetism. We know that the direction of magnetic field lines from north to south for magnet, and they will form a closed loop. There is no point. There is no thing like it will start from one point and it will end at the other point, which we see in electrostatics. I mean, when you come to the topic of electrostatics, you will have two charges which are separated. One is a positive charge and another one is a negative charge, so that the field lines will start from positive charge and it will terminate with negative charge. That is why in the beginning of this chapter itself I told you that in electrostatic, electric monopoles are exist, but when you come to the chapter of, concept of magnetism, you cannot see a magnetic monopoles. So here, you cannot separate the two poles. The two poles exist together as a north and south. That is why the field lines will not start from one point and it will not end or terminate at another point. They will form one closed loop. I also draw the image of this magnetic field lines also. They will form a closed loop. There is no starting point, there is no ending point. So this is this concept you have to keep in mind when I discuss this concept. Yeah. So the main intention of this Gauss law is to find out the magnetic flux through any closed surface. I already told you that you have learned about the electric flux. So electric flux means it is a number of electric field lines which is passing through the given. For example, if I take a material like this, if I take the area like this, then the number of magnetic field lines, let me say this is the direction of electric field lines which is passing through this area. So the number of field lines which is passing through the area can be called as electric flux. In the similar way, if the magnetic field lines are passing through a given area, given the same area, then it is known as a magnetic flux. Okay. So here the Gauss is trying to find the magnetic flux through any closed surface. And if I wanted to say about this scientist, Gauss is a very famous scientist and he is a very genius mathematician. He was born in Germany. And that scientist who invented telegraph for the first time, he has designed the electric telegraph. Such a genius he was. So that scientist has given a law in magnetism and he considered a closed surface. So surface should be closed, it should not be open. So in order to explain this, let me get a closed surface. Let me say this is a closed surface. So I am considering a closed surface. Surface is closed here. There is no openings. And through this surface, there are number of field lines which is passing through this area. This element has some area through which the magnetic field lines are passing. This is the direction of magnetic field lines which is passing through this area. And Gauss is trying to find out what is the magnetic flux through this surface. That is what he tried to calculate. So here the area we have considered is very large here. So we have implemented the same procedure while finding any quantities in physics that we will take very small piece of an element and we will try to calculate whatever we wanted to do, and then we will take the whole element. So that is the procedure we follow while coming to the physics. And here also to find the magnetic flux. I told you that magnetic flux means it is the number of magnetic field lines which are passing through this given area. That is known as magnetic flux. And in order to calculate the magnetic flux through area, we have to consider in very small area. So it will be helpful for calculation purposes. If you take a very small area, then you can integrate or something mathematical way you can find it for whole area. So that is the concept we follow here. So let's take a small element, or let's say small area. Let's cut this whole area into small areas. Let's say the area of this is let's say that as a delta S. This is the area delta S. And let me show you, this is the area vector, direction of this area vector, that is n cap I am showing here. And at this point, the direction of magnetic field is like this. So this is the area vector, and that area vector forms an angle theta with the direction of the B. So to find out magnetic flux through this, he formulated one equation, and that equation can be written as magnetic flux through delta S is. I am telling you, we are calculating the magnetic flux through a very small area, that is delta S. We are calculating through the very small area. That is why the magnetic flux should be very small. That is why we will take delta phi b. Phi b means it is a magnetic flux. Phi b it is a representation for magnetic flux, and delta phi b means it is a very small quantity of magnetic flux through the area delta S. That delta S can be calculated as a B dot into delta S. So this is the formula God given to calculate the magnetic flux through any given surface. That is what B dot delta S. So this is the magnetic flux through this area, that is the delta S. Then what will be the magnetic flux through whole area? Then what we have to do? We have to take the sum, or we can say we have to take the integration. But they are one and the same. I can say summation, taking the summation over all the whole elements, or I can say magnetic flux through the whole area by integrating it. They are one and the same. So let me write the summation here. Then what I am trying to find here is I am trying to find the magnetic flux through the whole area. So net magnetic flux through whole area is, what we have to do is delta phi b is the magnetic flux through small area. Now you have to take the summation. Okay? It is all elements. I told you that we will split this whole element into small pieces as small areas, and now we have to sum all the areas. Take the sum of it. So if you take the sum of it, then you will get the net magnetic flux, total magnetic flux you will get. So phi of b means it is the summation of b dot delta s. So this is all. So what will happen is, which gives the value is equal to 0. So this is what said by Gauss. Is that from this equation what we can say is the net magnetic flux, whatever we calculate is the net magnetic flux. The net magnetic flux over a closed surface will be equal to 0. Why? Because he has given the reason that the number of magnetic field lines entering this will be equal to number of magnetic field lines which is going out from this area. So there is no storage of lines in that surface. So whatever the field lines are entering, that much of field lines are leaving the surface. That is why magnetic flux in that region we can see. This derivation tells that the magnetic monopoles are not exist. But let's take the case of Gauss law in electrostatics. What he told is the number of field lines in that electrostatic number of electric field lines which is passing through that surface is given by E into delta S. So just imagine that that surface has some charges. Okay, it can have a positive or a negative charge. So what will happen? What happens is when a electric field line is entering that surface, that has to end at some point. We know that the electric field lines start from one point and it has to end to another point. That is the negative charge. So against the positive charge, whatever is present in that material, it will have some electric field lines. That is why the number of electric field lines which is entering that region will not be equal to the number of field lines which is leaving that area. That is why in electrostatics the electric flux was not zero. Because when you go to the electrostatics, we can see the electric monopoles. Positive and negative charges is separated. That is why we get electric flux for any closed surface. But when you come to the chapter of concept of magnetism, the magnetic flux through any closed surface will be equal to 0. Okay? Because the magnetic field lines do not start from one point or do not end at another point. That means whatever the area we have, in that it has some magnetic moment. There will be a magnetic moment, but there is no possibility of existence of magnetic monopoles. There are always dipoles, and that magnetic field lines will move the closer to. There is no starting point, there will not be ending point, or I can say there is no source of this magnetic field lines, or there is no sink of any magnetic field lines. So they will form the closure loop. So there is no storing. There is no storing of magnetic field lines in this area. That is why magnetic flux through any closed surface containing these two surfaces, it has two surfaces, that will be equal to 0. So this is given by Gauss. That is why this is known as Gauss law in magnetism. That is why what we can say is the net magnetic flux through any closed surface will be equal to 0. So this also given us the idea that I told you that magnetic monopole doesn't exist. Yes. So let me write a definition for this. Definition. For any closed surface, magnetic flux through any closed surface right? Net magnetic flux through any closed surface is 0. So this is the Gauss law, and it is very, very important for your exams, and will be asked for 2 or 3 marks.